Hello, everyone. I'm Einat Yelin, and with me I have Raz Ashkenazi. We are from the PM group at CATO Networks, and today we would like to discuss private application access, which is a core part of Universal ZTNA, and how we do it with CATO.
I'll just add that this was an educational session. We haven't showed anything new. So the goal wasn't to share features that we just released. The goal was to align everyone that we can do private access. And we have all kinds of features to support private, secure, and seamless private access. And we're going to improve this offering in the coming future.
So the use case is pretty simple. We want to provide secure and seamless access of a user to a specific application that will allow that user to have the access in a strict and secure manner. The user can be an employee. It can also be a contractor or a guest. And of course, they can, nowadays, they can reside at home, at the office, coffee shops, or actually everywhere. While the application can reside on-premise or can be hosted in the cloud. So this private access, is actually a very core and fundamental part of Universal ZTNA. So we will start by a bit of an explanation what UZTNA or Universal Zero Trust Network Access actually is. For that, I will use a great illustration by Gartner. So Gartner used the castle illustration to show what makes the Universal ZTNA different than traditional VPN solution. So in this illustration, actually, the network resembles a castle. And visitors to the castles are actually the users that are trying to reach certain applications, or in this case, certain rooms within the castle. So where in traditional VPN solutions, the visitors to the castles only needed to be identified and perform some checks at the castle gates. And once they cross the bridge, they will be able to access all the rooms within the castle and wander around the castle. In user TNA, it is not enough for the user to access the network at the beginning. They are also performing checks, ongoing checks on the user. They are required to be identified while they wander around the castle. And whenever they want to access a specific room, they need to unlock a specific lock. So access is actually more granular and checks are performed ongoing and continuously. And to write it down as principles, we can use the following 5 principles that say exactly the same. So essentially, identity access, centric access. So everything is done based on user and identity. And it is done everywhere. It's universal, as we said, no matter where the user tries to access from. The access is context aware, so it's not only based on the user identity, but also on the things like device posture and risk scores that are allowing to make better decision whether to allow or deny the access. Of course, there's the least privilege access. So as we said, users cannot access all the rooms or all the applications, but it is more granular and narrowed down to only specific applications. Next, we have the secured encrypted traffic. So traffic must be secured so that it can't be exposed to externals. And lastly, we have a continuous verification. So as we said, users need to be identified every once in a while and are not only being checked upon the first access. So please remember these 5 principles. We will see how CATO implements everything within its solution. So going to CATO solution, actually, it is comprised of 3 different building blocks. On the left-hand side, we have the CATO user, and we have the CATO user access solutions. On the right-hand side, next to the applications, we have the CATO socket as a connector to the application. And in the middle, we have the CATO SASE cloud. Let's start with user access. So this component actually is responsible for the user awareness, as we said, identification and authorization of the users, Then device posture to make sure that device stands to the policy that the admin asked for it to stand for. And then access control. And when we talk about accessing and user access, we don't only talk about the client. Client is the most used way to connect users to applications, but we also have the clientless solutions. We have the application portal, and since last quarter, we also have the CATO browser extension. So I'll put here just a summary of the differences between the three accessing solutions. Essentially, what's important to note is that all of them provide user awareness and integration with SSO providers. Of course, security is performed and access is controlled no matter which access method is being used. And application granularity can be done with whatever solution is being used. So for all solutions, let's start with seeing how we implement the user access control in the user solution. So the first case is a remote user on a managed device. It's an employee. The first thing that this user needs to be doing is to authenticate. And this can be done with SSO. We have integration with several IDP solutions. And as we said, this is done all the time. So it's not only done at the beginning of the session. The admin can decide the frequency where the user has to be re-identified again and again throughout the sessions. The next phase is conditional access. So here we check things like, is the device posture okay? Is disk is encrypted? Is there an EDR running and to the right version and things like that, as well as the user risk score. So if the user is identified as compromised, then access is being dropped. As we said, it's done continuously, not only when the user tries to access in the first place, but also throughout the session. Then we have the application-specific control. So we do it with CATO with the one firewall, and permissions, as we said, are narrowed down to the explicit applications. And only after the user is going through all these stages, then there is a connection to that application and to that private application. So that is the remote user on a managed device. As we said, we have clientless solution for unmanaged devices where software cannot be installed. Then we can use either the CATO browser access the portal or the CATO extension that will have one access very, very soon. And also for managed user in the office. So they go through the same phases of authentication, conditional access, and then specific access to the application control. And if you remember, we just reviewed the different key principles of UZTNA, and we can see some of them already here. We have the continuous verification of the user and the risk score. Then the authentication is done everywhere, no matter if it's in the office or remote users. And then it's context aware, and we make sure that not only the user is identified, but also it's standing to the right policies of posture and scores. Now let's move on to the second module, second part for the user to application access, which is the CATO socket in the context of application connecting. Raz, this is for you.
Yeah. So we have a few methods of onboarding private applications to your CATO tenant. One option is to use the socket as the gateway. As we all know, a SASE gateway, an internet gateway, and then it means that all traffic is routed through the socket to the CATO cloud. And another option is to use the socket for specific use cases, only for private access, where the socket can act as a non-gateway appliance, meaning it allows you to integrate with an existing third-party internet gateway or a NAT gateway if we're talking about a cloud environment. So those are the two methods. Please click, Einat. And both methods, can you click, Einat? So Yeah. So both methods are supported for all socket form factors, whether you're deploying your vSocket from the marketplace of AWS or using a physical 1500 socket. Both or all options are fully supported to be used either as a gateway, so all traffic will be routed to the CATO cloud, or as a non-gateway. Click. So we're going to cover a few use cases, four actually. And what's common to all use cases, another click, please, Einat, is that the socket will automatically initiate an outbound tunnel to the closest and best performing POP location. Meaning the socket is deployed in the premise, whether the premise is a cloud environment or a physical environment, and then it identifies the best performing POP location, so you don't have to worry about it. It creates it in an automatic manner. Now, starting from that, you can configure some policies, basically, and then allow the actual access of users to the applications behind the socket. So we see three different use cases. We'll start with the left one, with A, where the socket is a gateway, meaning it serves all protocols or applications, and then if an application needs to access the internet, it can through the socket. Of course, there's all kinds of engines that allows you to do it in a secure manner, and also traffic coming towards the application through the socket is supported. Going to B, B is an option to use the vSocket as an app connector for a specific application. So you can deploy the vSocket or the socket within your premise and then expose only specific IP addresses or specific applications. In this example, you're exposing only a specific application to be actually accessed from users behind the CATO cloud. Going to C, basically very similar to B, but here we are allowing to access a few applications, meaning you can expose one subnet, two subnets, a few applications basically, so you can do it at your convenience basically, according to the use case and the demand. Click. The fourth use case also adds another layer. We call it hide not. Basically, you can hide all incoming traffic towards the application behind some IP. Usually, it will be the LAN IP of the socket. This allows for all kinds of possibilities, and we'll talk about it in a few minutes. Now we're going to deep dive into each and every option. We're going to start with A, B, C, and D. So for A, again, the default next hop for all traffic will be the vSocket. So in this case, all subnets in Azure, as an example, will route all traffic. So the destination is everything, a 000 route. And the next hop will be the vSocket, meaning all traffic will be routed through the vSocket. So it is responsible both for the inbound traffic and also for the outbound. It is the gateway of the site. Click. And the second option is basically where you're using the vSocket as an app connector. So you can either create a specific route in the routing table or do all kinds of manipulations. We will talk about it in a bit. But here you can see that all subnets are forwarding the traffic to the internet through a gateway, which is, in this example, it's a firewall. So if an application wants to access the internet, if it needs to download some software image or whatever, it will route the traffic towards a third-party gateway, a NAT gateway, a firewall. But this vSocket is deployed here because users need to access an application. So the actual, in this example, the 192.168 range basically represents users behind the CATO cloud, right? So the users can access the application in a symmetric manner. Click. So going back to C, so basically B and C are very similar, where the only addition or the only change is here that we are exposing a few applications. So again, you can go granular and expose a single application or a few applications, one subnet or two subnets or 10 subnets. It depends on basically the use case, whether you're doing a gradual migration to CATO or you want to have a few vSockets there. So you can just do it according to the use case that you're trying to solve. Next. And here we have the use case where we described another layer, the layer of hide not. Basically, it means that the CATO cloud will translate all incoming traffic towards the application behind an IP. In this example, I'm hiding all inbound traffic towards the specific applications, right? And I'm hiding it behind the same socket LAN IP. And basically, once NAT is done, two things are basically available. One, because we're using the LAN IP of the socket, you don't need to perform any routing changes because the actual application will identify or will recognize this traffic as a LAN IP, right? So you don't have to have any routing or any route changes in the environment. And two, Inat, if you can please click another one, is that if you want to have another layer of security and make sure the traffic is actually routed through the CATO cloud toward your application, you can add this actual IP into an access list in your premise, and then only traffic coming through the CATO cloud, which was NATed, right, which was translated behind this IP, can access your applications. So this is just another layer, and basically you can do whatever you want, policy-based. You can choose which IP you want to use for the access, and this is what it allows you to have. That's it. Back to
Thank
you.
you. Yeah, thank you, Rad. So this actually covers the socket part of the solution, and we, as Rad demonstrated very well, it provides you a least privilege access. So access is very granular and can be provided to a single application or to multiple applications, depends on the policy and the routing that you perform. So the last piece of the puzzle is actually the CATO SASE Cloud. And this is another important module. Actually, the CATO Cloud is the one responsible for transferring all the traffic, of course. And we make sure, because we have the backbone of more than 85 POPs already, we make sure that no matter where the user is or the application resides, we always have a POP nearby to take care of the traffic. And the second thing that you need to understand about the CATO SASE Cloud and the POP solution is that everything, all the capabilities, all the access control policies, all the risk scores calculations, all the different algorithms that we do in order to make sure that access is provided in the secured manner that you wanted, everything is available on all the POPs everywhere. So each machine within each POP has the exact same capabilities, and you can be provided with consistent policies, and traffic doesn't need to go from POP to POP in order to perform all the actions. And then, of course, it's a single pass architecture. So encryption and decryption is done only once, and everything is done on the same machines. So we keep the delays to minimum, which of course contributes to the seamless experience of the user trying to access an application. And we know how important that is, because the minute it's not seamless, then users try to tweak and try to find tricks to tweak the systems and to overcome the security controls. So this also covered the secured and encrypted traffic, which was the fifth key principle as part of the universal ZTNA solution. So with that, we actually can summarize that we saw how the different CATO models, the user access, the CATO socket, and the cloud, they were designed and actually were built from the ground to answer the key principles of universal ZTNA that were listed. And while this architecture is very sophisticated and it operates actually behind the scenes just to provide customers with a seamless and straightforward experience that they would expect, we make things behind the scenes, and all the complications are kept away. So actually, the user can perform the access without even knowing what's going behind all this architecture.